Hello everyone, I Dr. Odhesh Kumar, Assistant Professor, Department of Computer Science, MMB, Banaras Hindu University. I welcome you all in this course titled Digital Logic and Circuit Simulation. In today's lecture, we will discuss about what do we mean by demultiplexer and what are the application of demultiplexer. In some previous classes, we will already discussed about what is the meaning of multiplexer. Multiplexer generally convert a large number of information into a single line output, and just reverse operation we can perform by using a demultiplexer. One input information is supplied to large number of output, but at a particular moment of time only one particular output is active. Let us discuss here what is the meaning of it. Is generally a combinational circuit that accept a single input and distribute it over a multiple output lines. So, generally demultiplexer accept a single input line and that distribute the input it to a multiple output lines, but at a particular time only one input goes through goes to only one particular output line. Now the question is which output line input goes. So simply this is determined by a selection line, or that is also called as a control line. Now the question is what is the, suppose there are in a block diagram of demux general block diagram is what, there is a one input line, single input line is there, the maximum 2 to the power n possible, what is 2 to the power n output lines are there, and at a time only one output line is active. There are, this depends on the number of selection line. This is 1 of 2 to the power n demux. This is also in short it is denoted as a demux, that is known as a demultiplexer. Here the input is what, the single input data line, data is goes through input, and which output is selected as a input, this depends on the number of selection line. And suppose all the selection lines are 0 0 0, this means data, input data goes through a output line I0, output line Y0. So there are n number 2 to the power n maximum output starting from 0, suppose the output is Y0 and Y1, similarly this is what, Y to the power n minus 1. Selection lines are used to control behavior of demultiplexer, and out of 2 to the power n output lines at a time input is sent to only one output line, and it is determined by values of number of selection line. What happens in case of multiplexer? There are 2 to the power n input lines, one output lines, and n number of selection lines are also there in case of multiplexer, but it's which particular input goes to a output, this is determined by a number of selection lines in case of multiplexer. Here in case of demultiplexer, out of 2 to the power n output lines, which output line input is selected, this determined by a number of selection lines. Here there are different types of multiplexer, demultiplexer, like 1 of 2 demux, that is also called as a 1 cross 2 demux. Similarly 1 of 4 demultiplexer, 1 of 8 demultiplexer, 1 of 16 means only one input lines, 16 output lines in case of 1 of 16 demultiplexer. Similarly 1 of 64 demultiplexer, 1 input line, 64 data lines, 64 output lines, and only 6 number of selection lines in case of 1 of 64 demultiplexer. Now what is the block diagram and functional table of 1 of 2 demux? 1 of 2 demux, this means this is the general block diagram of 1 of 2 demux. There are 2 output lines named as a Y1 and Y0 and Y1, only one input lines that is named as I, whatever the value of input, either I0 or 1, and which particular output line input goes which particular output line, this depends on the selection line. Here this is 2 cross 1 demux, this means 2 to the power 1 cross, this is written as 2 to the power 1 cross 1 means one number of selection line, and suppose the selection line is what, yes. When yes is equal to 0, this means the output Y0 is selected and I goes to y0, whatever the value of y0, this means when s is equal to 0, there are two possible value of selection line, s is equal to 0 and s is equal to 1. When s is equal to 0, y0 is selected as a output, y0 is active and I is sent to a y0, and when s is equal to 1, I is sent in a y1, that is y1 is equal to what? I, and whatever the value of phi, when I is equal to 0, this means here y0 क्या होगा? 0 होगा, and when I is equal to 1 होगा, then y0 is equal to 1. Similarly, in that case y1, when I is equal to 0, that means y1 is 0, when I is equal to 1, this means y1 is equal to 1. So, this means whatever the value of input, only single input means two possible values are 0 and 1, and this 0 and 1 means this particular input is supplied to one of the output lines, either y0 or y1, and which particular output line input is supplied, this depends on the number of selection line, and here the selection line is only single selection line S, when this means the value of selection line is 0, this means the input is supplied to output line y0, and when this S is equal to 1, the input is supplied to output line y1. And we directly write a Boolean expression for output function y1 and y0, this means y1 is written as what and y0 is written as what? Y1 is what? When S is equal to 1 and whatever the value of I, this is written as simply Si, and y0 is what? When S is equal to 0 means S complement is 1, and this is whatever the value of I. This means simply we implement the logic diagram, circuit diagram of 2 cross 1 multiplexer. We know the output value y0, y0 is directly written as what? Y0 is nothing in terms of S complement, this is S into whatever the value S0, S complement and value of I, and y1 is what? When S is equal to 1 and whatever the value of I. Simply here we take the selection line, and this after applying a NOT gate here, this is a S complement goes from here, and then simply we take a single input line, and this particular input line is connected through a complement of this, and we simply provide a AND gate here, and this is what? Y0, this is what? Input, output y0, and this is output y1 is what? S into I, S is goes from here, S is taken from here, I is taken from here, and we simply connect both by using a AND gate, this is y1. So, this is the circuit diagram of 1 of 2 mux. Similarly, block diagram and circuit diagram of 1 of 4 demux. 1 of 4 demux means that is also known as 1 of 2 to the power 2 demux. Here this 2 indicates the number of selection lines. Number of selection lines. Here what is the block diagram? There are, in case of demultiplexer, only single, there are 2 to the power n output lines are there, 1, 2, 3 and 4 output lines are that as named as y0, y1, y2, y3, and only single input line, and that is what? This is a input, this is a outputs, and this is what? Number of selection line there are 2 to the power, this is 1 of 2 to the power 2 demux, this means there are 2 number of selection lines are there, and which output is selected as a input, this depends on the number of selection line, and suppose these selection line are S1 and S0. When the value of S1, S0 both are 0, 0, then input goes through output y0. When this is 0, 1, then input goes through output y1. Similarly, when S1, S0 are 1, 0, input goes through output y, and when both are 1, 1, input goes through output y3. Then simply we write it, this is the implementation, this is the functional table of 1 of 4 demux, the number of selection when 0, 0 are there, which output is selected as a input line. This means here y0 is selected, means whatever the value of I, that is represented through a output y0. When I is 0, this means y0 value is 0, when I is 1, the y0 is 1, and rest of the inputs are 0, rest of the outputs are 0 0 0. When this particular combination of selection line 0 1, then output is what? Which output is selected as a input? This y1 is selected as a input. Similarly, y2 is selected as input when the value of s1 s0 is 1 0, and similarly when the value of s1 and s0 are 1 1, this means y3 is selected as input. This is not a 1, this is simply a I. This is I, this is I, not a 1, this is I, this is I, means the value of whatever the value of I means either 0 or 1, the output is same as, means the value of y0 when in this particular combination of selection line 0 0, whatever the value of I is 0 or 1, that is reflected through output y0. Similarly, whatever when in the combination of input selection lines are 0 1, whatever the value of input, that is reflected through a output line y1, and rest values are 0 0 and rest outputs are 0 0, and similar case happens with a selection line value 1 0, then whatever the value of I that is reflected are displayed through output y, and similarly when both selection lines are 1 1, then output y3 is selected as I, and whatever the value of I that is reflected through the output y3. So, let us here we directly derive the output from this functional table. So, here Boolean function for output y0, y1, this is a 1 of 4 demux. This is the block diagram of 1 of 4 demux, and here we directly derive the output y3 is written as what? When both s1 and s0 are 1 1, and whatever the value of I. Similarly, y2 is what? When s1 is 1, s0 is 0, this means this both are 1 1 into I, then this means the y2 is reflected whatever the value of input that is reflected through y2. Similarly, when the value of s1 and s0 are 0 1, then whatever the value of I that is reflected through y1, and similarly y0. So, let us draw a logic diagram of or circuit diagram of 1 of 4 demux. Here what are the output value y0, y1, y2 and y3. y0, y1, y0 is written in terms of what? This is what? S1 complement, S0 complement, and this is I. Similarly, y1 is what? S1 complement, S0 I. Similarly, y2 is written as S1, S0 complement I. y3 is written as S1, S0 into I. Let us take here, one is the input variable when we design circuit, that input is I value is either 0 or 1, and another two are taken here as S1, this is S1 complement. Similarly, here S0 and this is S0 complement, S0 complement, this is S1 complement. First input is what? Both complements and I are connected through a AND gate. Here there are 3 input AND gate. Then second is what? Second is S1 complement, S1 complement goes from here, and third is what? S0, S0 is taken from here, and third input is what? I, second AND gate that represents a y0, that represents a y1. Similarly, third is what? 3 inputs are S1, first is what? S1, S1 goes from here, and second is what? S0 complement, S0 complement goes through here, and I is taken from here, and these 3 are connected, this represents a y2. And similarly, for y3 is what? S1, S1 goes through this input, and then second one is S1, S0, S0 is goes through this, and I is goes through this input, this is y3. So, this is the logic circuit diagram of 1 of 4 demux, and we can, when we supply the value of S0, S1 and I, we simply derive this functional table of 1 of 4 demux. Similarly, we can design the block diagram and logic circuit diagram of 1 of 8 mux. One of block diagram of 1 of 8 mux, there are 1 input lines. Here there is a 1 of 8 mux demux. There are 1 input line 3 selection lines are there, that is written as what, x, y, z, and the next one is the 8 output lines that is known as y0, y1, y2, y3, y4, y5, y6 and y8. We design a functional table and we directly write when the value of x, y, z all are 0, 0, this is I, input I. Then we directly write a combination y0 is written as what, this is nothing but a x complement, y complement, z complement into I. Similarly, y1 is written as x complement, y complement, z into I. Similarly, y2 is written as what, x complement, y, z complement into I. Similarly, y3 is written as x complement, y, z into I. y4 is written as what, x, y complement, z complement into I. Similarly, y5 is written as x, y complement, z into I. Similarly, y6 is written as x, y, z complement I. Similarly, y7 is written as x, y, z into I. In this way, and we also implement, there are 8 AND gate are required, each of 4 input AND gate, and we also implement just like as we design a circuit diagram of one of 4 DMUX, we also design a circuit diagram of one of 8 DMUX. This is the block diagram. Now the question is, suppose how we design a large size DMUX using a small size large size DMUX using a small size. This is one of the application of demultiplexer. We use a small size, like as a design a one of 4 DMUX using one of 2 DMUX. Here we know that in case of one of 4 DMUX, how many inputs are? Only single input, that is represented through a variable I. Outputs are 4 outputs that are named as y0, y1, y2 and y3. There are 4 outputs. And how many selection lines are there? 2 selection lines there, that is selection lines are 2 and that are named as suppose x and y. In case of one of 2 mux, because we want to implement a one of 4 DMUX by using one of 2 DMUX, this is what, simply number of input line is single, input is 1, that is represented through I, and simply output lines is what, outputs, 2 outputs, that is represented through y, like as here the output lines are represented through P0 and P1, and similarly selection line is also 1. We know the block diagram of one of 2 DMUX. Here for representing one of, how many outputs are there? 4 outputs are there. In that case, simply for representing a 4 output, how many DMUX of size? One of 2 DMUX is required, one of 2 DMUX are required. This is one of 2 DMUX. This is also one of 2 DMUX. Here there is a single input line, 2 output line, this is named as y0, y1, this is named as y2 and this is what, y3. There are 2. Now because we know that in case of 1 of 4 mux or 1 of 2 to the power n mux, only one input line is there, there are 2 input lines, then again there is a need of one of, this is one of 2 DMUX, one of 2 DMUX, and this means again there is a single input line. This input line, through this input line I is supplied here, and now what is the selection line? Here the selection line of in this stage are common, and that selection lines are what? This is a selection line this is a selection line, this is selection line y, and similarly this selection line, only one selection line is there, is x. When x is, what are the output here? When x and y, when x and y, x is 0, y is 0, what will be the output? When x is 0 means input is selected through this particular line, and here y is also 0, this means which input is selected, this is input is selected to y 0. Similarly, when x is 0, x is 0 and y is 1, 0, y is 1, then simply when x is 0, this particular input is selected as a input is selected as this particular output line, and when again y is 1, this means what? This particular output is selected as input line. So, here y1, this is represents a y1, similarly y2 1 0, when x is 1, this particular output output is selected as input, and when again there y is 0, this means this particular, this is represents a y2, similarly y3. In this way we represent a 1 of 4 demux by using a 1 of 2 demux. Similarly, how we simply implement a 1 of 8 demux by using 1 of 2 demux. How we implement 1 of 8 demux by using 1 of 2 demux? Here 1 of 2 demux for representing 8 outputs, how many 1 of 2 demux are required? 4 demux are required, 1 of 2 demux, each of size 1 of 2 demux. This is, in this stage there is a one selection line will be there, and that selection line is common in all. In case of 1 of 8 demultiplexer, there are 3 selection lines equal to 3, output lines is equal to 8, and input is 1. Input lines are 1. Here this is the input line, this is also input line of this multiplexer, this is also input line, this is input line of this, and here through this Z is coach, and now here this is 1 of 2 demux, this is also 1 of 2 demux, this is also 1 of 2 demux, this is also 1 of 2 demux. Then outputs are, 2 outputs are there, 2 outputs are there, 2 outputs are there, 2 outputs are there. Then there are 4 inputs are there, again here there is a requirement of 2 demux or each of size 1 of 2 demux. Then again there is a need of 1 of 2 demux. There are 2 outputs, again 1 inputs are there, 1 inputs are there, and one selection line, that is what? The selection line is what? This selection line, this is suppose y, here this is another input line, and then again these, for connecting these 2 input lines as a output line, there is a 1 of 2 demux is required, and this is a final input line. This is an input line. This means how many demux are required to implement a 1 of 8 demux. How many 1 of 2 demux? To the number of 4 plus 2 plus 1, this means 7 demux, 7 1 of 2 demultiplexers are required to implement 1 of 8 demux by using 1 of 2 demux, and here these are the output lines here, and this is this final selection, this is the selection line is what? X. And again whatever the value of here, the value of x, y, z, when the value of x, y, z are 0, 0, 0, when this value of x is 0, this means this particular output is selected as an input, and when again this is 0, this particular is selected, then again this is 0, this means this is selected as a output, that is y 0. Similarly, 0 0 1, this is selected y 1. Similarly, 0 1 0 0 1 0, this means when this is x is 0, this is selected, then y is 1, this means this one is selected, and this is 0, this means this is y 2. Similarly, y 3, y 4, y 5, y 6 and y 7. In this way, we can implement a large size demultiplexer, or we design a large size demultiplexer by using a small size demultiplexer. And now, the application, another application of demultiplexer is implementation of Boolean function using demultiplexer. It is very, we already discussed the implementation of Boolean function through a multiplexer, and in a similar way we also implement, we use a demultiplexer for implementing a Boolean function. And when implementing a n variable Boolean function through a demultiplexer, we use 1 of 2 to the power n demux. For representing n variable Boolean function, or for implementing n variable Boolean function, what is the size of demultiplexer required? Simply we take 1 of 2 to the power n demultiplexer. Like as for implementing, if the Boolean function is what, f of w x y z, that is written as suppose w x complement plus y z, this means what is the suitable size multiplexer required for implementing this Boolean function is what? Suitable size multiplexer is what? 1 of what? n 2 to the power n, there are n means 4 variables are there. So, this means 2 to the power 4, that means 16, that is written as y 0, y 1, y 2 and up to y 15. Total 16 outputs are there. Then what is w? All the Boolean variables are taken as a selection line here, x, y, z, and sorry, w, x, y and z. This is 1 of 16 demux. In case of representing a 4 variable Boolean function, similarly for representing a 3 variable Boolean function, we simply take a demux of size 1 of 8 demux. For representing a 3 variable, for representing a 5 variable Boolean function, we simply take a 1 of 32 demux and so on. And when we represent, all the variables are taken as a selection lines, all the variables are taken as a selection line of demultiplexer. And what is the important thing here, the input value of when we implement a Boolean function through a demultiplexer, simply the input of demultiplexer is taken as 1, means we supply 1 through the input, because only single input is there, then means we can supply a constant value 1 through that particular input. Here now let us take example, implement a Boolean function f of w x y z is equal to this, and another Boolean function f2 is equal to this. When we implement a Boolean function w complement x plus wy complement, f2 is what, w, then first we write both function in standard SOP form. The f1 is written as what, f1 of w x y z standard SOP form. This f1 containing what terms, that is what, w x means w x y z, this is the term containing to w complement x, this is fixed 0 1, this 0 0 0 1 1 0 1 1, this value is 0 1 0 1 0 1. Similarly, another is what, w y complement, and this is w x y z, w is 1, y is 0 1 0 1 0 1 0, these are constant, and rest are 0 0 0 1 1 0 1 1. This means simply what is the min terms here, this represents a min term what, m4, this represents m5, similarly m6, and this is m7, similarly what, this is m8, m9, m12 and m13. This means this is nothing but when we write it in standard SOP form, it is written as summation of 4 5 6 7 4 5 6 7 8 9 12 13, 8 9 12 13. Means when we determine the output of this function in these particular min terms combination, the output is 1, and rest combination the output of function f1 is 0. Similarly, we also write a standard SOP form of second function f to w x y z, that is written as what, summation of wx, this is nothing but a wx, when wx means a second function, this is the function f1, and when we write a f2, f2 is what, first term is what, wx y z, wx is represented like 1 1 0 0 0 1 1 0 1 1, that is 1 1 1 1 1 1, that is fixed. Second term is what, wy complement, so this is wy complement w x y z, w is what, w is fixed, that is 1, y is fixed, that is 0 1 0 1 0 1 0, and this is what, 0 0 0 1 1 0 and 1 1. This means this is min terms m12, m13, m14 and m15, and similarly this represents m8, m9, m12 and m13. Here m12 and m13 are present in both terms wx and wy complement. This means we write only a one occurrence of that particular min term. So, this means the min terms written in sequence are, that is what, 8 9 12 13, 8 9 12 13 and 14. When we implement this, what is, how many number of variables are used to represent both Boolean function? There are 4 number of variables are used to represent. What is the suitable size demux? We simply take a 1 of 16 demux, 1 of 16 demux. This is just like as a implementation by we use a decoder to implement a Boolean function. Similarly, we use a demultiplexer to implement a Boolean function. So, here we use a 1 of 16 decoder, 1 of, this is 1 of 16 demux, and these are the output y0, y1, y2, y3, y4, y5, y6, y7, y8, y9, y10, y11, y12, y13, y14 and y15, and simply here these are the outputs y0, y1, y2, y3, y4, 5, y6, y7, y9, y10, y11, 12, 13, 14 and 15. Then what is the means, simply we connect, there are 2 OR gates are required to implement this function with this demux. For f1 is at 4 5, this means this is 4 4, this is simply 4 5 6 4 5 6 7 6 7 8 9, this is 8 9, then 12 and 13 9 10 11 12 and 13, all are connected through a single OR gate, means when any one of the min term is 1, the output value is 1. This is represented through a f1 is represented by this OR gate, and 8 9, similarly here 8 is taken from here, 8 is taken from here, 9 is taken from here, 8 9, then 12 13 14, here 12 is taken from here, 13 is taken from here and 14 is taken from here, and there is a 1 OR gate. This simply represents a function f2. In this way we use a demultiply, and what are here, all the variables are taken as a, all the Boolean variables w, x, y and z are taken as a selection line. So, these are the selection line, this is input line. We always provide a input value 1 in case when we represent a Boolean function through a demultiplexer, and simply 2 functions are represented through a demux. This means there is a 2 OR gate, and how many number of min terms in each of the function. So, the number of inputs in OR gate are, suppose the function f1 containing a 8 number of inputs, this means this is a f1 is connected through a 8 input OR gate, and here simply f2 is represented through a 5 input OR gate, because it has a 5 min terms to represent a function f2. So, this is overall about a demultiplexer. Generally here in this class we discuss about what is the meaning of demultiplexer, what are the various application of demultiplexer, like as a demultiplexer, by using a small size demultiplexer, how we design a large size demultiplexer, and also how we use demultiplexer to implement a Boolean function. Thank you very much.